Hello everyone, welcome to Make Tiny ML YouTube channel. So in this video, I'm going to explain about my new project, Home Radiator Breakdown Detection System using Edge Impulse software. So this Edge AI software will detect is there any issues in your boiler or if your home is not heated up properly and give an alert to the your homeowner or the customer. So that's the high level of this project. So the problem statement which I took as is like in a normally in Western countries, if it's in a very peak winter time and if the homeowners are away from the home for a week or a month, so there is a chance if the boiler doesn't work properly or not heating up the home properly. So if it may go to the negative temperature and then all the pipes in the homes will be frozen and there is a chance it can burst off, and this will cause lot of maintenance costs and loss to insurance company. So this is the problem statement I took, and what kind of edge AI solution I'm trying to provide here is like I developed the model and deployed to the one of the microcontroller which will keep on running and detect whether is the boiler is on for some particular amount of time, and then it will measure the temperatures, the home temperature is there, like the boiler is keep on but the home temperature is started reducing. So that means there is something problem in the boiler or something problem in the radiator. So that's the high level one. Let's go to the project. I'm sharing my screen. Yes. So the complete end-to-end project is I documented in my Hackster page. You can go to my name, Manuanan, and you can able to find this project, Home Radiator Breakdown Detection using Edge Impulse software. For this project, I used Edge Impulse software where you can train your model with connecting your hardware and deploy back to the hardware. And there are a lot of options, like if you want to edit your code to add some more applications on top of your machine learning prediction, you can able to do. That's what I have done for this project. I will explain in the later stage now. And as a hardware, for an hardware, I use the Arduino port and the H7 and the temperature sensor to read the home temperature. Yeah, that's the overall. And how to use the just architecture I want to explain. So the architecture wise is simple. I'm going to fit that Arduino port and H7 with the room temperature near to the boiler. It will keeps on recording like the real time boiler sound, and the model will predict whether the boiler is on or off, and that's where the machine learning comes. So I'm training the model with, okay, when the boiler is on and when the boiler is off, just a noise data, and then it will predict whether the outcome is just boiler on or off. And also it reads the temperature, the room temperature, and it predict, okay, the boiler is on for these many times but the temperature is not improving or it's decreasing still. So that's how it predict, okay, some there is some issues in the boiler system. And how to connect this hardware to the Edge Impulse software. So there is a detailed documentation. You have to download the firmware, connect to your hardware, and flash that firmware to the board. So everything is clearly mentioned here. I don't want to explicitly mention again. You can just go through this page, and once you connect everything and once you flash that, go to your command window and type Edge Impulse daemon, and then if you go to your project, you can see that it's connected to your device. And so in any machine learning, right, so the first thing is data collection. So we have to collect the data and we have to label it, whether it's a what kind of scenario we're going to address. So here for my project, it's a boiler on or boiler off. So I simulated to make my boiler run, and I just kept my Arduino port and H7 near to the boiler and keeps recording the data. And I have used the MFE pre-processing for the audio processing data, and then the classification, that's a classifier, normal neural network classifier, and then the output features will be whether a boiler on or boiler off. So you can see that, and the window size I used as 2000 milliseconds, is 2 seconds, and the stride increase will be 1000 milliseconds. And you can see that, and the generated features, you can see that it can clearly classify, okay, boiler on, boiler off here. And let's go to the neural network. Here I use the normal reshaping layer to for the 40 column, and then the one dimensional convolution layer, and then the dropout just to have a more accuracy. So I have a dropout rate as 0.25, and then again the 1D convolutional layer, and then dropout, and then I'm just going to flatten that. That means it's going to be a single column of data after that, and it's going to have a normal 40-20-10 the neurons ratio. And then this is the overall neural network architecture I used, and then I'm able to get the very good result. You can see that result. And also it's not only the training, and I have to test it. So I whenever I was collecting some data, I used to get some data not into I'll put some data not into the training. I will just separate it and I will use it for the testing side. So everything is possible. When you are collecting the data, there is an option you can just move the data whatever you want. So everything is here, data acquisition. Let's say when you record the data, you don't want to use that data for a training, but you want to use that data for the testing. You can just click here and you can say move to test data. So that's a lot of option. And sometimes you want to record it for 60 seconds, but you want to split that into 5 seconds each. So that is also possible, like a split sample. Or if you want to just get some particular sample time of data, you can use the crop sample. Yeah. And the deployment, that once model is tested, everything is fine, you want to deploy it back to the hardware. And there are a lot of options out there, but for my project I use the Arduino library, because my project is doesn't ends with just boiler on or boiler off. My end goal is I need to analyze and say, okay, the boiler is on for some particular set of time, and there is no any much progress in the heating. That means still the temperature is getting dropped in my home. So that's where my prediction. So I need to have some application code on top of my machine learning model. So I just used the Arduino library and downloaded the basic library, and on top of that I added my logic. So just the application what I'm the logic will be like this one. So you can see the algorithm what I used. Yeah, so the graph is not that good, but yeah, I'll improve it in the next time. So it's just a simple one, like we are starting the timer and measuring the room temperature, and if the boiler count is on, that means the boiler is on. It will increase some boiler count to by 1. So let's say in the 30 minutes, uh, in a 30 minutes, if the boiler is on for 15 times, I mean 15 minutes, that means it will run every minute, and it okay, the boiler is on or off. So let's say if it's more than 15 times, if the boiler is on, then that means it will go and say, okay, boiler is on for some considerable amount of time. So then we need to see whether there is a significant increase in the temperature or not. So here, if the temperature still remains same or it's getting decreased, that means there is some potential problems in our home heating system. Maybe the radiator is not working fine, or maybe the gas, the pressure level in the boiler is not enough. So even though simply boiler will be on, but there is no any improvement in the heating system. So this is what this entire algorithm works. So I have the Arduino. I mean, on top of the machine learning model, we have to add this application code. Everything is added here, and this is in the my Git project. You can see here. And the schematic is nothing but just between my Arduino Potato H7 and the my temperature sensor, how to connect it. So this is the complete pin details you can see. Yeah. And so yeah, once you deploy the code, and if you can get that my code from the git. So the git has this one, Radiator breakdown detection version 1. And for a prototype version for initial testing, I just use 30 seconds, like but typically in a real time scenario it should not be 30 seconds, it should be like 30 minutes. So every 30 minutes it should check, not a 30 seconds. But for a demo purpose it's a 30 seconds. You can just change it when you want to really deploy it to your home, but for a prototype and for testing, so it's just flexible. I'm using that. And yes, This is a pretty much code. Like I added my application code on top of the machine learning prediction. Yes, in this one. Yep. Yep. So this is like kind of timer, some particular timer, what events we have to do, and you can see that boiler count is greater than the threshold count. That means is boiler is on for some particular time of period of time in the last 30 minutes. Then we have to check what's the temperature, and it's still checking it. Yeah. Yeah. So this is the overall one. Let's go to the demo now. Yeah. I flashed the software now, and I just kept the Arduino Potento at 7 near to the boiler, and I just simulated the boiler to run. Uh, Now you can see that the outcome here. So here you can see that it is detecting the boiler is on, and the count is, that means now for the quick testing I just keep on running for every second. It can be configured to minute. Now you can see that boiler count is keep on increasing. So you can see that temperature check where it shows that radiator breakdown, check boiler. So that is the detection. Now just for the simulation, like I just run it for 30 seconds where you can just let me show that. Yes, temperature check. So that means there is no any significant increase in the temperature, and it runs and detect, okay, the boiler is keeps on for 15 times in the total 30 seconds of timer. So if there is any significant increase in temperature, then it will predict, okay, there is something issues, so we have to check it. So yeah, as I mentioned earlier, we need to just change the code. Instead of seconds, we have to check it for every minute. That means instead of 30 seconds, we can configure to check for 30 minutes. It can do that exact check, and then if it's the boiler is on for more than 15 minutes, then it, and there is no any significant increase in temperature, then it will predict, okay, there is some issues. Yeah, thank you. I hope you liked my project video. For many AGI projects, please subscribe to my Make Tiny ML YouTube channel. Thank you.